My name is Evgeni Gousev. I'm from Qualcomm AI Research, also chairman of the board of tinyML Foundation. And today we are here with Kate. Kate, can you
Hi,
tell?
everyone. I'm Kate Kallot, and I'm the head of emerging areas at Nvidia, but also the chair of tinyML for Good working group. Really pleased to be with you all today. So maybe we should get started by you, Evgeny, telling us what tinyML is and how it came together.
Yeah, no, I think tinyML is a very interesting, very dynamic, very young field of machine learning and artificial intelligence, very broadly speaking, which has actually a lot of potential in terms of making a big impact in our society in all the dimensions, like in the commercial space, in the for good space, in the AI democratization space. And in a nutshell, it's a set of energy efficient machine learning techniques, approaches, hardware, algorithm, software, basically end-to-end type of things that enable on-device analytics at extremely low power. So that's kind of the key definition of tinyML. Is it's all about energy efficiency. It's all about low power type of application, low cost type of application, and it's end-to-end type of systems that include tinyML. And there are like many examples of tinyML applications around us in all the verticals around us. So we started kind of also to continue my introduction. We started tinyML in Qualcomm about 7 years ago. And at that time, it was one of the pioneering projects we developed here on tinyML Vision. And I think soon we realized that the opportunity is going to be very significant. We started to partner with companies like ARM, Google, Microsoft, and many others to build ecosystem around, because again, for new technologies like tinyML, you really need to build this kind of massive ecosystem where people can work together, can develop products together, can do research together, can do things together. So that's kind of where we are today. So we started tinyML Foundation in 2018, and I think 3 years after now, we are in about 30 countries, 29 countries around the world, 7,000 people, many companies, supporters involved in tinyML. It's really a massive momentum, and all of them, it's all about, again, energy efficient AI, energy efficient machine learning. So what is your journey, Kate, into tinyML? How did you start there?
Well, my journey is a bit special because at the time when tinyML was created, I was still working for ARM, and my team was also looking at how we integrate better with the tinyML Foundation movement, and how we go and build applications that developers can use, or at least optimize some of the software that's being integrated with Google, like TensorFlow Lite Micro, to make it usable for developers on microcontrollers. So my journey with tinyML actually started a year and a half ago, almost 2 years ago now. At the beginning of the movement, and since then it's grown massively. We as a team built a ecosystem of partners while still at ARM, which was really focused on machine learning on microcontrollers, and that ecosystem of partners has expanded massively, and the team is carrying on this legacy and continue to driving engagement with partners in this space. But then it kind of bifurcated a little bit, because as we were engaging with the developer community, as we were engaging with partners, it became very apparent that tinyML had a kind of like sustainable angle to it, because if you look at microcontrollers, these are extremely low cost, low power devices that could be used in areas of the world, including emerging markets. So this is kind of looking at the nature of the market and the nature of the applications that were built there on tinyML platform. It could have a for good angle, and I think, Evgeni, that's one of the reasons why the tinyML Foundation, the tinyML for Good working group was created, right?
Yep, that's absolutely true. I think because we see a lot of opportunities there, and it kind of comes both from the top down, from kind of us seeing how these technologies can be used, but also from the bottoms up, like when we talk to people in different parts of the world about tinyML technologies and opportunities, people come up with all kind of interesting use cases, interesting problems to be solved by tinyML. Many of these problems are kind of, again, in the commercial space, but there are quite a few, and there are more and more coming in the for good space. And when we talk about for good, I mean, for good is a very broad term, like tech for good, AI for good, tinyML for good. So what are the for good angles of tinyML, Kate, you see from your angle, from your kind of interactions with the world?
So if you look at the vision of tinyML at the core, it's really trillions of intelligent devices that are enabled by tiny machine learning technology. But building on top of that, you could orient this vision and complete it by saying that with this technology and with those applications, we are really trying to improve the ways billions of people live and interact with each other every day, and contributing to achieving the Sustainable Development Goals. For the audience who is not familiar with the Sustainable Development Goals, or we also call them the Global Goals or the SDGs, these are a kind of collection of 17 global goals. It's basically a world's to-do list designed as a blueprint for the world to achieve a more sustainable future for all. They were set by the United Nations General Assembly in 2015, and they are intended to be achieved by 2030. So for a few examples of the global goals would be no poverty, zero hunger, would be also a goal around climate change. Would be a goal around responsible consumption and production, would be a goal around life on land or life below water, reducing inequalities, achieving sustainable cities and communities. So when you look at those 17 goals as a whole, it becomes really, really apparent that technology can play a big role. And the technology ecosystem for tinyML for Good is a mix of low power, low cost, and easy to use. But the ecosystem at its core is a mix of industry, researchers, and developers. So if you put all these people and all this technology to work to build applications that can help advance the global goals, this is what we've been trying to achieve by creating the tinyML for Good working group. And really the way we are organizing this group, because we won't be able to solve the 17 global goals as tinyML for Good working group, but what we've tried to focus on is to take on 3 different areas. The first one is healthcare. How can we use some of the technology and the applications, or enable developers to build applications that can help solve some of the challenges that are faced right now in healthcare. So, for example, these students in Kenya that I had actually met at the DevSummit in 2019, back in 2019, in December in San Jose, they came from Senegal, 2 students who came from Senegal. We had great chat. They took the courses, we had a workshop on tinyML taught by Pete Walden at the time. They went back to Senegal. A couple of months later, they reached out to me after COVID hit. They reached out to me and they sent me this beautiful application where they built a robot who is helping the doctors in Senegalese hospital serve patients remotely. So the doctors don't have to always interact with the patients. These are kind of like autonomous robots who are helping the doctors and the nurses to care for patients. this was all built on tinyML application. The second area where we're looking into is STEM. How can tinyML through applications maybe built through on the microbit platforms, for example, help advance, make advancements on the STEM side. The last one is actually everything that's related to climate conservation and earth data. And for this, an example of application would be around Dr. Shira, who I think is giving a workshop actually at the DevSummit this year. Him and his students at the Dikut University in Kenya took a platform based on a simple microcontroller and built a system that can monitor the Kenyan rivers. There was a problem. There was a problem on the Iwaso Nyayo, which is one of the major rivers in Kenya, which takes its source from Mount Kenya and goes all the way down to the Indian Ocean. And this river is actually serving as a lifeline for a lot of communities around. You can think about farmers, you can think about pastoralists, and there is an increased demand for water to irrigate the crops, but also there is a big land degradation and reduced rainfall in the region, and that's all this combined is destroying the catchment area, and it has led to water shortage in the region, but also conflict between the communities. So what they needed is an effective system to monitor the water and to monitor the river. And they built that system on a Cortex-M based platform with a few sensors and a LoRaWAN transceiver to collect data, monitor the river, but you're also using machine learning to deal with abnormal sensor measurements and make predictions. The first device that they deployed in the wild was actually funny enough, destroyed by baboons, something that no one could predict, including machine learning, right? But they redeployed it, and right now they're hoping to build and to develop more at scale low-cost devices that can be capable to continue monitoring the river, but also monitor other rivers in the country. So these are the kind of applications that are coming up from the community, which is already part of tinyML, and examples of how developers in the tinyML space are using the core technology that we're building us as technologists and applying it to problems which their local communities are facing.
Yeah, Kate, you brought so many good points in such passionate way. So it's like it's amazing. I think I can just add to this. I think about a year ago, I looked at these 17 UN sustainability goals, and I kind of counted like how many of those can potentially be solved or helped by the technology, and tinyML in particular. And I found like I think 10 or 11 of them would be really kind of a good fit. Like if you do matching technology to this type of problems, and we do them at a global scale, I think that would make a big impact there. And I think you also mentioned STEM. I think that's kind of a very, very important area here. Education in general, and in particular education in the parts of the world where people don't really have enough access to the technology, to this type of knowledge. And I think that's where tinyML as a technology and tinyML as a community can also play a big role there, because the cool and actually very differentiated part of tinyML is the technology itself is very powerful, but the barrier to learn this technology is quite low. So in terms of getting hardware boards, you can get, for example, a Raspberry Pi Pico board, the whole board, not just silicon, the whole board for $4. $4 is less than a cup of coffee here in the US, or like a bottle of Coke or something like this. You can really buy a computer on a board for $4. And then there are many companies that offer software tools for free for this type of application, and you can plug it in and develop kind of your own applications like right away. I mean, there are classes offered by edX, for example, and Coursera. Those are free classes for people to learn and get up to speed. So really, kind of back to the STEM question, it becomes quite affordable in many ways, in terms of time, in terms of money, to learn these technologies, and then you can see problems around you in your country, in your part of the world, and you can apply them. And I think this is a very powerful value proposition. This is a very powerful momentum, and it's not just us dreaming. Although I think Kate and I, we are dreamers in a way.
We are.
Yeah, but we are not the only ones, right? I think there are quite a few of us, and I think thanks to Kate and her colleagues, I think I've been introduced to many amazing people in the world, and I have not been interacted with before. In particular, folks in Africa. We have 4 tinyML groups in Africa, in Kenya, Nigeria, South Africa, and Morocco, and kind of we're building more, like in Zanzibar and other parts of the world. It's like over 1,000 people. But when you talk people in these countries, you really see kind of the passion and how much these people are grounded in terms of trying to use technology to solve problems around them. It doesn't have to be like a huge problem, but any small problem that is solved today kind of leads to a big problem solution in a year, in a week, in a month, that time frame. So I think this is super powerful. Again, the STEM, the education, the talent around the world, it's just amazing. I mean, when we look at the world from the Silicon Valley here, where I'm based, it's like a big bubble, but it's not what the world is. I mean, the world is like, it's like people in Asia, people in Africa, people in South America, people really live lives and try to make a big difference at their level. And I think that's where we believe that's where and why we believe tinyML is so powerful, and it's so impactful, because it can make a difference like right there, right now, and really in a very affordable and scalable way.
There is a great question in the chat which says, what tinyML can do that traditional machine learning couldn't, and why one should go to tinyML particularly?
Excellent question. I think three answers to this. I think one is for example, if you want to run like big object recognition, you need to have a cloud connection. You need to have quite a bit of processing time, and like your cameras, you need to plug them into the wall in terms of electricity. So what tinyML can do, because it's extremely low power type of technology, it can be operated on a battery type of devices, and it can be deployed like for a very, very long time. I mean, some applications can last like up to 10 years or so on a battery. So that's kind of one thing, just kind of one example. This is like what we have. This is technology we productize in Qualcomm. That's a tinyML vision. You can see it's really tiny, it's small. And because it consumes very little power, you can have this type of vision devices deployed in many, many places. So it's really kind of, one is energy. That's what makes it different. Second is privacy, because this type of devices, they do analytics, on-device analytics, right at the device level. You don't need to send data to the cloud back and forth, and by design, these devices keep privacy inside of the device, so you don't need to worry about those things, especially for vision type of applications, audio type of applications. People are getting more and more concerned about privacy for a good reason. So I think this technology solves it fundamentally at the technology level, at the device level. Again, this is a big differentiation compared to traditional ML. And the third one, I would say, that's what I mentioned earlier, is at the people's level. I think to become like a ML application type of guy, you really need to work for a big cloud type of company and kind of do all this type of things. To start your own tinyML company, you don't really need to do it. I mean, the barrier, as I said, is quite low. Like one example, I think we've been talking to our friends in Kenya, tinyML friends in Kenya, and they started a company they called iBees. I use this example quite often these days because it's just so amazing what they did. So what they did, just an illustration, they put a tinyML device inside of the beehive, and they, by monitoring temperature, audio, chemical signals, vibrations, they can define the state of the the B family, and if there are any kind of risk events happening there. And in Kenya, it's a big business. There are like 90,000 farms there, and apparently they're losing 30% of the bee population like every year. So by doing this kind of things, you can save the problem there. So basically, the point I was trying to make is that tinyML is relatively easy to learn, to deploy, and to use, and build some applications and businesses around them. Those are the three differences. One is the power, which is battery operated. Second, privacy, and three, kind of easy to use.
There's a follow-up question to that. Can you recommend some devices or ICs with tinyML?
Yes, I think that's another good news about tinyML. I mean, there are like a dozen of companies offering this type of things. It really depends on what problems you are trying to solve. Some of them are to solve vision-related problems, just like the one I showed. Some are more on the audio side of things. Some doing multimodal type of applications. Some of them have connectivity. Some of them don't have connectivity. So it really depends what problem you're trying to solve. I think like this week at the DevSummit, there were several announcements. Several companies offered their products. ARM is quite active in this space. Some companies use ARM cores to develop this type of thing. So it really depends on what you try to solve. I don't want to mention any particular names here because there are, like, as I said, half a dozen companies. I mean, the easiest, you can send me email. It's evgeni@tinyML.org, and I will kind of point you to some of these companies, depending again on what applications you have in mind. Is it audio, vision, sensor, vibrations? And also same also applies to the software tools. I mean, there are a lot of like AutoML software tools, like how do you do tinyML without coding? I think these techniques have become, software techniques and tools are becoming also more popular.
There is another question around where should people go to learn about developing on tinyML?
Yeah, I think, well, kind of in general, the best resource to get involved, go tinyml.org website. There are tons of links and resources there. If you're interested in tinyML for good in particular, there is an email you can send for good, like for like letter 4, good, one word, at tinyml.org with your ideas, your questions, and we'll do there. In terms of formal education classes, we have tinyML educational activities there. We have 4 working groups: tinyML for developing world, tinyML for K-112, tinyML for translations, and tinyML STEM groups. So those are educational activities. I think in terms of formal education, there are probably 2 most popular classes today online. One is EDX tinyML class. I think that one is very popular. It was organized by Harvard in collaboration with tinyML Foundation. That one has like about 60,000 students enrolled, and it's a free class if you don't want to take a certificate. If you want to take a certificate, you have to pay a little bit, like a few $100s. So again, it's something maybe the tinyML Foundation can help you with this too, if you need some support there. And I think there is also a Coursera class on tinyML. Also, it's free if you don't want to have a certificate, and there is a little bit of money involved if you do want to get a certificate. So those are the 2 today, probably most popular ones, but there will be more coming.
Last question from the chat: is there a role of tinyML in education, and at what levels?
tinyML for education, yes, I think at many levels, starting from really basic work that can be done at the school level. We are talking to some high school teachers, really getting them up to speed on tinyML. There is this K-112 type of activities. That's one level. The other one is at the university level. I think we hear a lot of universities are getting involved in this, doing really good research, good educational type of activities there. And kind of at the community level, because the tinyML community is a very diverse. It starts from like 5 years olds and going to, I don't know, 100 years old type of people. So like I said, an illustration, we just had a tinyML Vision Challenge under tinyML Foundation. Was 52 submissions out of like 500 participants, and there were 5 awards, and one of the awards was given to a team of students ages from 5 to 9. So they got an award for developing a smart bird feeder using tinyML technology. It just again shows how easy to use this, and it has no boundaries in terms of continent, in terms of edges. It's really kind of your imagination and your passion, and then you can get these tools, you can get this software and hardware, and get it going.
It's amazing.
Yeah.
One more question. What sort of software development tool chain is available for tinyML?
Today, it's quite diverse. It started with TensorFlow Lite from Google. In fact, Pete Warden, one of our founders, he wrote a book. I should have it here. Yeah, I have a book here.
You did.
on my shelf. So this is the book. You can see the mirror image of this, but it basically says the tinyML. It's a rally book. So they use TensorFlow Lite here. So TensorFlow Lite has some libraries to be able to do the tinyML. But since then, there were several more companies getting involved in this space, and I think I'm pleased to see the companies are developing this AutoML tools or tiny AutoML tools. So basically, you don't need to be a data scientist or kind of a programmer to use them. So it's really easy to use. And there are several companies here. I mean, some that come to mind: Edge Impulse, SenseML, Kixo, Reality AI. Many companies offer these software tools that kind of become the interface between these big tools, frameworks, and the devices. And also companies like ARM and others, they have also their own software tools like Qualcomm. We have our own software tools that come with hardware. So again, think about this more kind of from the problem statement, and then we can use any of those tools. And yeah.
And that was the last question. So how, maybe to close, can you tell us how do we get started with tinyML for good? How to get involved?
Yeah, there are many resources. I mean, the good thing about tinyML for good, it's a new development, new motion. I think it's joining now is the right time to do it, and there's just so much excitement in the community there. Website tinyml.org is one place. Then the working group is forgood@tinyml.org. And then on November 17, we are going to have a tinyML for Good workshop. It's going to be live and online. I think Kate is the chair of this workshop. We are going to have an amazing program there, basically connecting technology people to people who know and who have these problems to be solved, like NGO and other type of organizations. So it's going to be again November 17th. Information on this workshop is on the website, tinyml.org. It's there. You can register. Thanks to the sponsors, this event is going to be free of charge, and it's going to be live like all tinyML events. So we keep them interactive so people can participate and join and discuss in things in real time. But after this, tinyML is the community, the type of organization. We want to make sure that people do projects together. We are going to start a tinyML challenge in the sustainability area. So keep an eye on the announcement there. So basically, we'll have some grant prizes for this, and kind of we want to make sure that people, the whole community, work together to solve these big problems, especially in the for good area and in the sustainability area. So many ways to be involved. Just connect to us, and we'll get it going.
Yep, looking forward for all of you to reach out to us.
Yeah.
David Tischler is asking, most important, what Twitter accounts should he be following?
Yeah.
Around tinyML.
Yep.
I think you have them all.
Yeah.
All right.
Yeah,
I think it's time to wrap up.
Yeah, well done, Kate. I think definitely we encourage the audience to join and share your ideas, your passion, anything you have. If you need any help, we'll help you there. And I think in the next few years we're going to see a lot of impact that tinyML is going to create in this space. Yeah, it's going to be fun, very meaningful and fun, and a lot of cool things will come out of this.
Really looking forward to the innovation and the new applications that developers around the world are going to come up with. And I'm thinking that I'm also seeing that tinyML for Good is triggering new tinyML chapters in Latin America and other parts of the world. So there will be a lot of things coming, a lot of good things coming out of these initiatives over the next couple of years. So really, really pleased to be part of the adventure and looking forward to have you all join us too.
Yeah, we don't know where it's going to take us, but we know it's going to be big.
We can dream. It's fine.
Yeah,
We're dreamers.
we can dream. Yeah. We are the dreamers.
Awesome.
Okay.
Well,
Okay.
thanks everyone for joining us today. Thanks, Evgeni.
Thank you, Kate. Yeah.
Take care.
Bye.
Bye.